these notes go over how to find like generating equivalent expressions and how to like combine like terms. The fill in the blank at the top is really sloppy, but what this word says is terms, and those are the parts of the expression that are separated by plus or minus signs. And then coefficients are the numbers that are multiplied by at least one variable, and you've heard the word coefficient before. It's the number that's attached to the letter when you're multiplying. And then like terms are the terms with the same variables that are raised to the same powers. So on this first example, we have 8y minus 3y, and I highlighted both of the y's because we can combine the two of them. If you have 8y's and you're taking away 3y's, then you would just do 8 minus 3, and you're left with 5y. You're combining the two of them because you can do that because they both just have a y to the power of nothing. On the next example, you have a and you have b as your variables. You have 4 times a to the fifth minus 2 times a to the fifth. So you can combine the two of those. They are both raised to the power of 5, and it's both an a. And then you have 4b plus b, and you can combine both of those because it's both just a b. Let's do the a's first. So 4a to the fifth minus 2a to the fifth, that would be 2a to the fifth because you're just subtracting 4 minus 2. And then if you look over here, 4b plus b, there's an imaginary 1 in front of that, so it's 4b plus 1b, so you'd be adding 5b. On this bottom example, I've highlighted what you can and cannot combine. Actually, I did that wrong. I didn't realize that was an m and an n. Let's just erase that. So 8m plus 14 minus 12 plus 4n. Don't do what I did and think that m and n are the same. Those two cannot be combined, but you can combine just the regular numbers. So in the middle you have a 14 minus 12, so you could simplify that to 2. And then it's just 8m plus 2 plus 4n. And you can't combine anything else on that, so that's as simplified as that one's going to get. Alright, on this side, oops. Yeah, that's right. 5 times x plus 4 plus 2x minus 3. First thing you have to do on this one is distributive property. With distributive property, you have to take the number outside of the parentheses and multiply it to everything inside the parentheses. So on this first example, you take the 5 that's on the outside and multiply it to the x and to the 4. So 5 times x is 5x, and then 5 times 4 is 20, and then you just take the sign that's in the middle. So in the middle is an addition symbol. Then just tack everything else onto the end. So you have a 2x minus 3. Now we can combine these, and we can combine these. So let's do what's in the circles first. We have 5x plus 2x, that would be 7x. And then you have plus 20, so a positive 20, and a minus 3. You always have to be careful what, like if it's addition or subtraction that's attached to it. So in that case, you'd be 20 minus 3, which is 17. So that's your simplified answer for this one. Let's do the next one. So you have the 6x squared at the beginning, and we can't touch that. First, we have to do distributive property. So 4 times x squared would be 4x squared. And then 4 times negative 1 is just negative 4. And you could have just thought of it as 4 times 1 and then kept the symbol that's in the middle. And then throw on what you have at the beginning. So 6x squared plus. So we can combine this with this. And there's nothing you can combine the negative 4 to, or the minus 4 to. So 6x squared plus 4x squared, that's 10x squared, and then throw on the minus 4 at the end. Alright, last one that I'm going to do with you. It says 2 plus and then x plus 5. This is still distributive property, but whenever you see it like this, where there is no number directly to the left of the parentheses, because if you look over here, there is a 4 right next to it, and on the first example there's a 5 right next to it, but over here there's nothing. There's technically a 1 there. So if you distribute the 1 to everything, 1 times x is just, you can put 1x or you can just leave it as x. And then 1 times 5 is 5. Keep the symbol that's in the middle so it's a positive, and then throw on what you had in the front. The only things we can combine here are the 2 and the 5, and it's a positive for both, so that'd be 7, and then throw on what's left, 7 plus 1x. I want you to pause the video and try to do the 4 that are on the bottom, and then when you're ready, hit play, and I will go over them. Here's my work for the first two. So if you distribute the 6 to everything in the parentheses, 6 times 2x, I got 12x, and then 6 times 5, so 12x plus 30, and then throw on the minus 3x at the end. So if you simplify and combine everything that you can, you would get 9x plus 30. On this example, 4x minus 3 plus 2, and then you have to multiply the 2 to everything in the parentheses. So I got this, and then I was able to simplify and combine the 4x and the 14x, and then I was also able to combine the minus 3 and the plus 20. So my simplified answer is circled in blue. The last two examples are a little bit easier. On this one, everything can combine. 4x, 2x, and 7x. Just add up all of your x's. So 4 plus 2 is 6. 6 plus 7 would be 13x. So there was no distributing on that. There wasn't even parentheses. On the last one, we can combine all of the s's. So 4s and 3s. That would be 7s. We can combine the regular numbers. So 8 plus 3, that would be 8, 9, 10, 11, 11, and it's plus. And then the 2d, there's nothing else to combine that with, so it would just be left as 2 times d. Make sure you have all that copied down, glue it in your notebook, and then go ahead and move on.